Do you want to remember the complement pathway in a fun and quick way? Are you struggling to remember all those C's and numbers and don't even remember yet? Is there any way to remember this pathway in an efficient and fun way? The answer is yes.
So tell me now.
Sure, let's begin. The complement pathway is a system of molecules, regulators and receptors involved in host defense against infection. First of all, consider that we have three variations of the pathway: the classical, the first ever known, the lectin 1, and the alternative. They all end up with the same final event, the cleavage of the protein called C5. Second of all, we can start to talk about the pathways. In all pathways we have a first event that begins the whole chain. In the classical pathway, the first event is the activation of protein C1q. So the binding of C1q to an immune complex antibody bound to antigen or to C-reactive protein. In the lectin pathway, the first event is the activation of protein MBL, mannose binding lectin, by microbial sugars. In the alternative pathway, the first event is the binding of protein C3 to microbial surface structures that do not include the sugars. So let's continue with the classical pathway and then simply make the variations. Have a look at this scheme. And try remembering the succession, it will be explains in a moment. C1q as you know, then C1r, then C1s, C4, C2 and finally C4 and C2 together become C4b2b. If C1 complex is not bound to an immune complex or to the C-reactive protein, then it is an inactive protein, consisting of 6 C1qs, 2 of C1r and 2 C1s. The globular part of C1 complex makes the binding and conformational changes activate C1r. C1r cleaves C1s. Finally, C1s cleaves C4 into C4a and C4b. Then C1s makes also the cleavage of C2, splitting it into C2a and C2b. Finally we have the final product, the C3 convertase, made of C4b and C2a. As the name suggests, the C3 convertase cleaves the C3 protein into C3a and C3b. C3 convertase is named also C4b2b, but it is made of C4b and C2a. So why such a name?
Do not go crazy here. You should know that complement proteins that end with the letter A are anaphylatoxins, so they are chemokines, while the B states that they are protein subunits.
As someone clarifies on Reddit, all the complement are like this. Except C2. C2 is backwards, with C2b being the chemokine and C2 are the C3 convertase subunit.
Your pain is all here, med student. I can't find anything on the scientific community finally agreeing to make the subunit nomenclature consistent.
So let's resume. We have C3 split into C3a and C3b. So according to what said before, C3a is the chemokine. It actually make mast cells on tissues, or basophils on blood circulation degranulate. C3b is the subunit of the final convertase. So C3b along with C4b2b forms that final C5 convertase. C5 convertase cleaves C5 into C5a and C5b. Again, C5a is the chemokine, same function of C3a but with the addition of being a potent chemotactic factor for neutrophils. C5b is the subunit of the final protein, which is not obviously another convertase but it is the MAC membrane attack complex. The membrane attack complex is made of C5b along with C6, C7, C8, C9. It brings to the lysis of the microorganism.
Before showing you the variations, I forgot to tell you that C3b is not only a mere subunit. It actually works also as an opsonin and mediates the clearance of immunocomplexes by linking them to erythrocytes.